In this lesson, I'm going to introduce the concept of polarity of molecules. But in order to determine whether a molecule is polar or nonpolar, there's some concepts that we need to review, and then also a couple of new concepts that I need to interject. So what I'm going to do is I'm going to actually teach all of this using one example. So if we have the example of NF3, what I want to review first is how to draw the Lewis dot structure of NF3. Now, if you'll remember, nitrogen has 5 valence electrons, fluorine has 7, but since there are 3 fluorines, you multiply 7 by 3, and so you have a total of 26 valence electrons. Now, in order to draw the Lewis dot structure of NF3, I'm going to make nitrogen the central atom, and then you have fluorine, fluorine, and another fluorine. Remember, these lines represent 2 electrons that are being shared by these 2 atoms in a covalent bond. Also remember that every atom except for hydrogen needs 8 valence electrons. So nitrogen right now has 2, 4, 6 valence electrons. It needs 2 more there to make 8. Each fluorine only has 2 originally, so it needs 6 electrons around it. So this is the Lewis dot structure of NF3. The other concept that we reviewed last semester is the shape. Now, we're going to be working with molecular model kits in class, but I just want to show you briefly what the shape of this molecule would look like. So we've got nitrogen here, you've got 3 fluorines coming off of that central atom. This shape right here is trigonal pyramidal. All right, so that's the review for you. We are now going to look at how electronegativity affects this molecule. So this is also a review from the last lesson we had. If you look at nitrogen and fluorine and compare them, fluorine is more electronegative than nitrogen. And the reason why is because it is farther to the right on the periodic table than nitrogen is. Remember, as you move from left to right on the periodic table, your electronegativity increases. So that's also a review, just knowing that fluorine is more electronegative than nitrogen. Now for the first new concept. Since fluorine is more electronegative than nitrogen, that means that it's hogging electrons towards it. And if you have more electrons, you have a negative charge. So since it doesn't completely steal those electrons, the electrons are just migrating more towards fluorine than nitrogen, we say that fluorine has a partial negative charge. All right? Since the electrons are moving away from nitrogen, we say that nitrogen has a partial positive charge, partial negative and partial negative here. All right, that brings up the next new concept for us to go over, which is this concept of a dipole. Now, a dipole is a region in a molecule with positive and negative regions. Positive and negative areas, I'll say. So if you look at this example, this is a dipole right here. You've got a negative region right here in the molecule, you've got a positive region right here. And the way that we represent a dipole is with an arrow. So the way I like to think about it, since electrons are being pulled towards fluorine, that's how you represent it. So the arrow goes towards the more negative, the more electronegative atom. So here again, your dipole would be represented like that, and again, like that. Now that we've discussed how to represent a dipole in molecules, what we'll do now is be able to determine whether a molecule is polar or nonpolar. Now, there are 2 different ways of determining this. First, what you can do is say, all right, do the dipoles cancel? Okay, that's one way of determining whether a molecule is polar or nonpolar. The second way is to ask, in a tug of war, would the molecule move? I'm going to use both of these explanations for each of these examples. All right, so if you look at this first example, CO2, if you notice the Lewis dot structure is already drawn for you, and it also shows the dipoles. So since oxygen is more electronegative than carbon, the arrow is going to be facing outwards, and then also this arrow is going to be facing out this way. Now, to answer the first question, do the dipoles cancel? So do these arrows cancel each other out? Well, since this one's pulling in this direction and this one in this direction, they're opposite but equal. They do cancel. And so if the dipoles cancel, then you have a nonpolar molecule. The other way to think about it, would the molecule move? Imagine a tug of war between these two oxygens. Since they're pulling with the same amount of force and in opposite directions, the molecule would not move, and therefore the molecule is nonpolar. In the next example, if you notice, you've got carbon with 4 chlorines. Chlorine is more electronegative, so you've got your arrows going towards the chlorines. I like to look at it this way. It looks a little bit less overwhelming. You've got arrows going that way, that way, that way, that way. If you consider the horizontal and the vertical aspects of these arrows, you've got the horizontal being pulled this way towards the left, this one towards the right. These actually will cancel each other out. Then you also have the vertical aspect. You've got something pulling up, but then you also have them pulling down. So these dipoles do cancel as well. Therefore, it is nonpolar. The molecule is nonpolar. If you want to think about it the other way, would the molecule move? If you imagine a tug of war of 4 different people pulling on this central atom, the molecule wouldn't move because you got that upward force, you got that downwards force, and then you got these horizontal forces canceling each other out. So if to the question number 1, do the dipoles cancel out? If the answer is yes, then you have a nonpolar molecule. To the second question, would the molecule move? If the answer is no, then you also have a nonpolar molecule. All right, let's look at a polar molecule example. I've got HCl. Now, since Cl is more electronegative than hydrogen, the arrow is going in this direction. So if you imagine, you've only got this one force. So does the dipole cancel? The answer is no, it does not cancel. There's no force going in the opposite direction. The second question, would the molecule move? Well, yeah, if you've got only one thing pulling in this direction, the molecule would move. Let's look at the last example. If you imagine here, since nitrogen is more electronegative than hydrogen, your arrows are going towards nitrogen. Okay, so now with the dipoles cancel, you've got forces horizontally going inwards and inwards, but you've got no force pushing downwards. These are all pushing upwards. So since you don't have an arrow pushing down, which would cancel the dipole is not canceled out. The other way to think about this, number 2, would it move? Imagine these forces are pushing on the central atom. There's nothing pushing down on it. Therefore, the molecule would move. So for a polar molecule, if the answer to number 1 is no, and the answer to number 2 is yes, then you have a polar molecule.